The Subcommittee on the Environment and Subcommittee on Oversight will come to order. Without objection, the Chair is authorized to declare recesses of the Subcommittee at any time. Welcome to today's hearing entitled An Overview of the Nation's Weather Satellite Programs and Policies. I recognize myself for 5 minutes for an opening statement and then to the ranking member as well. We've had a number of hearings about all kinds of issues related to satellites, from the current programs of record to commercial satellites. We've heard testimony about JPSS and GOES already once this year, and this is a second opportunity to do so. Some of the concerns that I have are the delay of the GOES satellite program that from March of 2016 to October of 2016. Obviously, this is a concern for the weather of our country, being able to predict and forecast accurate and timely weather events. Critically important infrastructure for the data that feeds our numerical weather models, which keep all of our constituents safe. So this is a good hearing. We have heard testimony before. Going along with the delay in GOES, we have an extension of the life expectancy of some of our current programs, and we have questions about if that is realistic or not. We have seen now NOAA 16 break apart in space over Thanksgiving, and that gives a lot of us concern about maybe it didn't just break apart on itself. I know some have suggested that, but something had to occur, whether it was a malfunction on board the satellite, even though it was beyond its lifetime, or it could have been hit by debris. Whatever the case is, it broke apart and now is contributing to more orbital debris, which is a concern. That being the case, you think about orbital debris. You think about the Suomi NPP satellite that also is coming to the end of its useful life, and it's not shielded. It wasn't designed for long-term service. It was designed more for testing and validation. So when you look at the NPP satellite, is it being pelted by debris? Is it at risk? And of course, would that create a gap as it relates to our polar orbiting satellite programs and the challenges that we've had with JPSS to date as well? We'd also like to discuss today NOAA's commercial space policy, which is a wonderful start to, I think, great opportunities for the future to provide more resiliency and redundancy, disaggregated and distributed architectures that the commercial industry can provide to augment our numerical weather models with data coming from the private sector and some of the issues that are going on there. And finally, the issues with debris mitigation, I think, are critically important, not only to NOAA, but to national security space and civil space as well, and commercial space. So I'm looking forward to this hearing, looking forward to the testimony of our witnesses, and I'd like to recognize now the ranking member, Mr. Byer, for his opening statement.
Thank you, Mr. Chairman, very much. And thank you, Chairman Bridenstine, Chairman Loudermilk, for holding today's hearing. I'd also like to thank and welcome our witnesses this morning. As been stated by our chairman, the goal of the committee's oversight in this area is simple, is to ensure that both the Joint Polar Satellite System, JPSS, and the Geostationary Operational Environment Satellites, GOES, are technically sound and operationally robust when they're completed, which we all hope is as soon as possible. As satellites that have a critical role in weather forecasting, losing coverage of either system could have serious, perhaps catastrophic effects on our public safety. Unfortunately, NOAA's development of both of these weather satellites has had a long and rocky path. They've been plagued by cost growth, poor schedule performance, technical issues, and management challenges. During the subcommittee's hearing on these projects in February, it seemed that JPSS was the more troubled of the two, but now it looks like GOES-R has now been delayed by more than 6 months until, as the chairman said, the new October 2016 launch date, which may still be at risk. These ongoing delays on these programs increase the cost of the satellites, distort NOAA's budget, and limit the agency's resources for weather forecasting and important research into weather, oceans, and climate science. We know that satellite acquisition is no easy task, and these problems are not unique to NOAA. They routinely occur in the development of satellite programs by the Department of Defense, the U.S. intelligence community, NASA, but this isn't an excuse. And I believe NOAA recognizes that this is an unsustainable model and that going forward, the agency will need to find a more efficient and more reliable means of putting its instruments into orbit. Shifting back to the work conducted by Mr. Powner and his team at GAO, it's my understanding that since 2012, they've issued 23 recommendations to NOAA that they believe will strengthen the agency's acquisition efforts and improve their contingency planning. But to date, just 6 of these recommendations have been implemented. So I'm interested in learning more about the remaining recommendations and NOAA's progress in addressing them. Additionally, I think it's important for Congress and this committee to have a clear understanding of NOAA's policies and planning as it relates to these critical satellites. NOAA's decision to change the expected lifespan of its weather satellites needs to be transparent and clearly documented. NOAA satellites also provide the data necessary for our weather models and the critical forecasting and warning products and services provided by the National Weather Service. In fact, the capabilities of the National Weather Service are directly dependent on the quality and the success of our satellite programs, as well as a highly skilled workforce. So while it's not the focus of today's hearing, I want to mention some important work that GAO is conducting on behalf of my colleagues, Mrs. Bonamici, Mr. Lipinski, and me. Specifically, we've been concerned about the number of vacancies that currently exist in the National Weather Service's field offices, and we've asked GAO to review present and future staffing levels in order to support the agency's efforts to evolve its operational components and to increase its decision support services. Ensuring an adequate workforce is also central to achieving NOAA's public safety mission. We can't afford a weather satellite gap, and it's essential that NOAA keep these programs on track. So I know that these are technically difficult and critically important issues that NOAA needs to address. So thank you, Mr. Chairman. Mr. Chairman, I look forward to today's hearing.
Thank the ranking member for his opening statement. I'd like to recognize the chairman of the Oversight Committee, Mr. Loudermilk from Georgia.
And thank you, Mr. Chairman. Good morning to our witnesses, and thank you for being here, Mr. Chairman. Thank you for holding this hearing. Today we'll be hearing from GAO and NOAA regarding the polar orbiting and geostationary satellite programs. The JPSS and GOES-R programs that NOAA maintains have experienced setbacks. Today we intend to learn what has changed since our last hearing back in February of this year. Earlier this year, GAO published a report detailing its concerns that the NOAA Polar Satellite Program, JPSS, is facing an unprecedented gap in satellite data. GAO believes that while JPSS remains within its new life cycle cost estimates and schedule baselines, recent rises in component cost and technical issues during development increase the likelihood of a near-term data gap. Additionally, although NOAA has recently reduced its estimated potential gap from 15 to only 3 months, GAO noted that this assessment was based on incomplete data and does not account for the risk posed by space debris to satellite hardware. This is even more concerning given that the recent breakup of a retired NOAA satellite in orbit. GAO estimated that in its report that a data gap may occur earlier and last longer than NOAA anticipates. Perhaps even more troubling is the potential data gap facing NOAA's GOES-R program, the geostationary satellite system. Since its inception, the GOES-R program has undergone significant increases in cost and reductions in scope, and as GAO's report indicates, NOAA has yet to reverse or even halt this trend, as we have seen with the most recent delay to the launch, pushing a March 2016 launch date back to October 2016. This means we could be facing a long period without a backup satellite in orbit. History has shown us that backups are sometimes necessary to reduce risk to public safety and the economy. In 2008 and 2012, the agency was forced to use backup satellites to cover problems with operational satellites, a solution we may once again find ourselves needing. When talking about the consequences of a gap in weather data, the first thought in the minds of many is the devastating effects of extreme weather on the ground. However, professional and personal experience allows me to discuss the impact of gap weather data on aviation weather. As a private pilot, I know the importance of having accurate and timely weather forecasts to assess flying conditions. Pilots require accurate weather data to evaluate conditions on the ground and in the sky throughout the entire flight process from takeoff to landing. Without accurate data, a pilot runs the risk of what we call getting behind the plane, a general aviation phrase which means the plane is responding to the conditions and the pilot is responding to the plane, a situation that spells trouble for even the most seasoned pilots. Experience as a pilot does not exempt someone from getting behind the plane as weather deteriorates, as I have conducted many search and rescue missions over the years, even led some of those. And without exception, every missing aircraft that we ended up finding as a result of weather resulted in a fatality. We were basically taking remains home to the family so they can be comforted they were found. Your experience, it doesn't matter. Even the most experienced aviators, when they get in a weather situation, it can spell disaster. One of those being Scott Crossfield. Scott Crossfield is a pioneer in aviation in America. He was the second to break the sound barrier. We conducted a search and rescue mission to find the remains of his plane as it broke up in a thunderstorm over northeast Georgia. My personal experience as well, once flying to Florida, I had accurate satellite weather data in the cockpit with me, which showed thunderstorms coming off the Gulf of Mexico. I was able to accurately determine not only that I should be able to beat the thunderstorm into my destination, but also alternate airports to my west that were clear and available. Without that, I could have ended up in a very difficult situation or not made it to my destination. As I was flying in, I also heard of other pilots who didn't have that information with Mayday calls being into the weather. With our reliance on GPS weather data, Mr. Chairman, I'm afraid that without accurate weather, these incidents would be more frequent. From this perspective, you can see how a gap in weather data and consequently less accurate forecasts could negatively affect not only commercial flight safety, but also the $1.5 trillion in total economic activity that the aviation industry contributes to the national economy. I hope that today's hearing will shed some light on the complex schedule and cost demands facing NOAA's weather satellite programs, and that the subcommittees will walk away with better equipped to consider these issues moving forward. And Mr. Chairman, I know that as an aviator yourself, you understand this as well, and I yield back the balance of my time.
Well, I'd like to thank the chairman, Chairman Loudermilk, for his comments. Certainly, I have been in those situations myself, and I appreciate your testimony on them. Let me introduce our witnesses. Our first witness today is Dr. Stephen Volz, Assistant Administrator of National Environmental Satellite Data and Information Services at NOAA. Dr. Volz has a PhD in Experimental Condensed Matter Physics from the University of Illinois at Urbana-Champaign, a master's degree in physics from Illinois, and a bachelor's degree in physics from the University of Virginia. Our second witness today is Mr. David Powner, Director of Information Technology Management Issues at the GAO. Mr. Powner received his bachelor's degree in business administration from the University of Denver and attended the Senior Executive Fellows Program at Harvard. In order to allow time for discussion, please limit your testimony to 5 minutes. Your entire written statement will be made a part of the record, and we on this committee have mostly probably already read it. I now recognize Dr. Volz for 5 minutes to present his testimony.
Well, good morning, Chairman Bridenstine and Loudermilk, Ranking Member Beyer, and members of the subcommittees. Thank you for the invitation to participate in today's hearing and to discuss the status of NOAA's satellite programs. As both of you or many of you have mentioned, NOAA provides environmental intelligence in a global way that is timely, accurate, actionable, and reliable space-based information to citizens, communities, and businesses as they need to stay safe and to operate efficiently. The NOAA satellite portfolio provides continuous satellite data that are integral to weather forecasting, and NOAA, working with NASA, conducts essential satellite development to ensure the continuity of this critical service. Our current operational geostationary and polar operating satellites provide, on a 24/7 basis, the space-based weather data required to support NOAA's National Weather Service and as well as the private weather industry and many other users who rely on those services as well. The geostationary satellites currently in orbit, GOES East and GOES West, provide constant monitoring from the Atlantic Ocean, the continental United States, Hawaii, and the Pacific Ocean for weather, and they are backed up by a fully functioning spare satellite, GOES 14, situated midway between them, ready to provide backup, as was mentioned as the need for, in the event of a significant satellite anomaly to either of the others. We are currently working towards an October 2016 launch for the next generation geostationary satellite, GOES-R. While we are working diligently towards this date, there are still risks ahead of us to get this new, highly capable and complex satellite launched on time. NOAA and NASA are working with contractors to identify and mitigate risks, applying all appropriate resources and expertise to meet this important launch milestone. To that end, we are monitoring the health of our current on-orbit assets to ensure that we maximize their operational utility until the GOES-R series satellites are launched, checked out, and placed into operations. Meanwhile, while that's going on with the flight hardware, the ground system for GOES-R and the user community continue to prepare for the launch and rapid exploitation of the new data stream once it begins. From the polar orbiting satellites, the first satellite of the JPSS program, the Suomi NPP satellite, is performing exceptionally as NOAA's primary afternoon polar satellite. 4 years into its operating mission, the high-resolution sounders of the Suomi NPP, ATMS, and CRIS instruments are continuously providing essential observations, feeding the National Weather Service's numerical weather prediction models, and ultimately the weather forecasts we all depend on. The Suomi NPP VIRS imagery has brought much improved observations of sea ice into the Alaska and Arctic waters, as well as new and much more sensitive VIRS low-light nighttime cloud imagery for that region as well. Weather observations from polar orbiting satellites are particularly important in Alaska and the polar regions where geostationary satellites cannot effectively observe. No later than in March 2017, the second satellite of the JPSS program, JPSS-1, will be launched, joining Suomi NPP in providing global coverage and increasing the data flow supporting the NWS and the user community. JPSS-2 continues in development, managed expertly by NASA and NOAA team, and is proceeding on schedule for a late 21 launch as well. NOAA's observing system includes, beyond these two satellite systems, the JASON-2 and Discover satellites, and soon will include JASON-3, the Cosmic 2 constellation of radio occultation measurements, and hopefully the Cooperative Research Search and Rescue mission, CDARS. These smaller and more focused missions provide essential environmental observations, augmenting and complementing the polar and geostationary platforms. In all of these systems, NOAA draws extensively on the expertise of academia and private industry, relies heavily on productive partnerships with other U.S. agencies, including specifically the U.S. Air Force and NASA, and on international agencies, including EUMETSAT and CNES and the National Space Organization of Taiwan, to meet our observing needs. We also are expanding our approach to access to space through the commercially hosted payload approach for CDARS to find more efficient methods of access to space. In closing, since joining NOAA just over a year ago, I have continued to work the work started by my predecessors to steadily rebuild the robustness of the nation's operational weather satellite constellations. Our current polar and geostationary satellites are aging, but are generally healthy as they continue to provide the observations enabling NOAA's weather and environmental monitoring mission. We are making steady progress to launch the next generation of polar and geostationary satellites in the coming year to continue and improve the reliability and quality of these Earth observations. NOAA works closely with NASA, our acquisition agent, and with our industry and academic partners to implement proven development processes so that we can meet our critical mission milestones. Decisions are continuously being made by individuals, governments, and businesses based on the weather forecasts. Space-based observations are vital to the ability of NWS commercial weather providers to produce and deliver these war forecasts. And NOAA values the longstanding interest of the committee in our satellite programs, and we appreciate the congressional support to ensure these critical national weather programs achieve a robust state that is needed to support the nation's weather enterprise. Thank you, and I look forward to the conversation.
Thank you for your testimony, Dr. Volz. You were right on the 5-minute mark, which is what we expect from our NOAA and former NASA folks. So thank you for that. Mr. Powner, you are recognized for 5 minutes.
Chairman Bridenstine, Laudermilk, Ranking Member Byer, and members of the subcommittees. Earlier this year, we testified on the GOES and JPSS satellite acquisitions. At that time, we expressed concerns about the GOES March 2016 launch date and potential gaps in satellite coverage. As we have heard, the GOES launch date has been delayed again. I will provide updates on both acquisitions by displaying 3 graphics which highlight key launch dates and expected lifespans of these satellites, many of which have been recently extended. On the first graphic, it displays the 3 GOES satellites that are currently in space. The first bar is GOES 13, which covers the eastern half of the United States. The third bar is GOES 15, which covers the western half. The middle bar is GOES 14, which is your on-orbit spare. NOAA's policy is to have an on-orbit spare if something goes wrong with one of the operational satellites. The red bars here represent an extension to the lifespan of the operational satellites from the last time we testified. When asked what this was based on, we were given a 2005 document supporting the lifespan extension. So a key question is why NOAA did not disclose this lifespan extension sooner. I'll add that in NOAA's 2016 budget submission, these red extensions were not included on their flyout charts. This is an area where NOAA needs to be more open and transparent with the Congress, especially since longer lifespans affect the timing of future launches and the annual funding of these satellites, as I'll get into on the next chart. But before we leave this chart, I'd like to comment on there have been problems with GOES 13 that have been mentioned, and the backup has been moved into operation several times. Also, currently a key sensor on GOES 13 has not been working since November 20th. Moving to the next chart, what this next chart does, the first three bars are basically just replicate what you just saw with the extended lifespan. The fourth bar represents GOES-R and the delay in the launch of GOES-R to October 2016. I have three comments on this chart. First, the GOES-R bar, the fourth bar down, the delay occurred due to technical problems and about 2 years of extremely poor schedule performance. The program was losing about 10 days per month for a 24-month period. Mr. Chairman, in our opinion, NOAA should have more clearly disclosed the poor schedule performance to this committee. My second point is the potential gap in backup coverage. The gold vertical bar here represents this projected gap. GOES 13, even with the lifespan extension, reaches the end of its useful life about mid-2016, and 14 and 15 are your operational satellites. So there is no backup in orbit from mid-2016 until GOES-R launches and performs a 6-month checkout through about March or April of 2017. And if the GOES October 2016 launch date is not met, this gap in backup coverage becomes even greater. My third and final point on this chart is the final two bars, GOES S and T. We agree that both GOES and JPSS need to have robust constellations to ensure continuity of coverage, and this is exactly why we placed the potential gaps in weather satellites on GAO's high-risk list in January 2013. But extending these lifespans requires a relook at the timing of out-year satellites. With the third chart, I'd like to move the discussion from GOES to JPSS, the polar satellites. As you can see here, the red arrow represents a 4-year lifespan extension on NPP, the current operational polar satellite in the afternoon orbit. We question whether this should extend to 2020 given NOAA's latest analysis supporting this. However, the good news here with JPSS is there is an annual review that is used to update the polar satellite lifespans, unlike the GOES programs. Regarding the J1 launch, the middle bar here, of March 2017, we are more concerned about this date than we have been prior. Key reasons are continued delays in the delivery of a key instrument, ATMS, continued delays in the ground system, and continued problems with the component on the spacecraft. And finally on the chart, we think there is increased risk with J2 since we have a new spacecraft contractor. On GOES, the story was that the performance will greatly improve with the delivery of the second GOES because there was a fair amount of learning with the first. It seems odd that that same logic wouldn't be applied to the second JPSS satellite. In conclusion, NOAA needs to be more transparent on risks in satellite lifespans. There needs to be a consistent policy to evaluate satellite lifespans, not just for JPSS, but also for GOES. And we still have major concerns with the the gap in the backup for GOES-R, and also between NPP and JPSS-1. But after GOES-R and JPSS-1 launch, given NOAA's recent extensions, we're really not concerned about gaps after that point. In fact, Congress might have opportunities to reduce annual expenditures on these programs in upcoming years. I look forward to your questions.
Thank you, Mr. Powner, for your testimony. I recognize myself for 5 minutes for questions. I just wanted to go back to Dr. Volz. The commercial space policy, I think, is a great starting point. I think there's more information that needs to be forthcoming on how to actually interact with NOAA on the commercial capabilities that are out there right now. One of my questions is, right now when it comes to GPS radio occultation, we already have one company with satellites in space that are being tested and validated through UCAR, and we have other companies that are going to be launching next year numerous satellites into space. We heard testimony from you, and it's in your written testimony as well, about the COSMIC program. When we think about commercial applications and we think about the 2010 space policy, commercial space policy, would it not be appropriate to take advantage of these commercial opportunities rather than continue to develop COSMIC for however many millions of dollars that's going to take?
So related to the value, the capabilities of the oncoming commercial capabilities, you mentioned we do have assets now in space. Spire is one organization that has launched some satellites, and there are several others that are likely to launch in the near term. And from the NOAA perspective, we're very interested in seeing the performance of these satellites demonstrated on orbit. The COSMIC program that was launched first in 2006 and has been flying for many years, providing radio occultation to NOAA and integrated into our numerical weather modeling, is a proven and demonstrated performance capability that we've been taking advantage of. The COSMIC 2 is an extension of that, and we expect when the launch occurs in about a year to add those observations into our data system. The value, the potential value of these new commercial ventures are very high, but it's still potential. And I see we should be engaged with them. We should be watching and observing and analyzing the data that come from them once we develop the appropriate interaction engagement mechanism. But it should be compared against some standard, some measurement capability that we have as well with COSMIC already. So I think the both and is the approach I would take in approaching these. I think we need the COSMIC 2 because it continues a necessary measurement, and it will provide an excellent benchmark in comparison for these alternative approaches which use the same method, the same measurement technique, but a different implementation. So validating those on-orbit activities and observations will be key as we go forward, and I look forward to the opportunity to do that.
Your boss, Manson Brown, last month here in D.C. at a business roundtable mentioned that he supports a line item in the President's budget request for a tech demonstration of commercial satellite weather data. Do you also support a line item for commercial satellite weather data?
I support my boss, which is a good start. I do support the principle that we do need a focused effort to demonstrate the capability of these operations. So yes, I would support that. I think, and we've been working within NOAA, with the commercial policy that went out and is now being reviewed for updates. On the NESDA side, as we do the actual implementation, we've been working on a process, an engagement process for how we would work with industry, work with potential vendors to provide data, to secure data, to evaluate the data when it comes in, and then decide whether it's capable of supporting a long-term operational contract or contractual mechanism. We had a workshop this Monday, which was well attended by all of at least 3 of the radio occultation potential providers, to talk about how we can have a productive interaction and how we can have a relationship going forward to support exactly that, which would be a demonstration project which could eventually lead to a sustained operational delivery of data.
The line item that Manson Brown talked about, any idea what that dollar amount might be that is going to be in the President's budget request?
I would be speaking from one half of the equation if I know, because I know what it takes for me to develop a satellite and to develop and to process the data, and that's what we're focusing on, what it would take for us to evaluate and to process the data. As far as what the commercial side would need as an investment or a procurement is a part that we still have to explore. So I'm not sure what would be the appropriate price point for our vendors to make their business models close, because obviously that's a very proprietary element on those. But
So
it's an engagement we need to have to get a better feel for that.
Right, and I would encourage you to engage with those vendors. The great thing for the taxpayer and for the people on this committee is that those commercial vendors are launching into space right now with clients that aren't necessarily NOAA, and that gives us an opportunity to share the costs so that it's not just the U.S. government taking on the burden, but also transportation companies, agricultural companies, insurance companies, et cetera, that are interested in this kind of data. So the price point may be a lot less than what we anticipate, and the idea that they're making the business case without the government involved is positive as well, which only makes it that much more interesting for us to be willing to reach out and purchase that data. I am out of time. I recognize the ranking member, Mr. Byer, for 5 minutes.
Thank you, Mr. Chairman, very much. Dr. Volz, I have a culture question for you, and it's not a hostile question. just to warn you up front. Mr. Powner talked about, quote, extremely poor schedule performance on one aspect of this. I read all of Rick Atkinson's trilogy on the war in Europe in World War II, and Eisenhower again and again gave impossible timelines to his generals for invasions of North Africa, Sicily, Italy, and Normandy. You read Walter Isaacson's book on Steve Jobs. Jobs again and again gave his team impossible tasks. So the question is, does NOAA surge? Do people work nights and weekends? Is there a sense of urgency about these things, and how's that urgency modeled by the leadership? Or is it business as usual, people come in at 9 on Monday morning and go home at 5 on Friday afternoon?
So to starting with the ending of what you just stated, I've not seen a more dedicated team working on any program that I've seen on GOES and JPSS, and that's independent of whether they're NASA, NOAA, Lockheed Martin, Ball Aerospace, any of our vendors. So there's no sense of casual execution of the program. There's a strong dedication to the mission and to the time and the effort they put into it, well beyond what I could ever expect to be telling them to do. So your observation related to is it a culture of setting unrealistic deadlines and expectations? We're very sensitive. I'm very sensitive to that. You do not want to set, if you set a schedule which is unachievable from the day one, then nobody treats it seriously. If I'm already behind the 8 ball, then it doesn't matter if I work extra or not. So it has a negative impact, I think, on performance. On GOES-R, when we set up the program some time ago, we have standard methodologies within NASA and NOAA about cost confidence and schedule confidence and probability of success. It's called a joint confidence level, JCL, for cost and schedule. And there's usually an acceptance that you budget to about a 70% confidence, which means 7 out of 10 missions will meet or exceed that, and 3 out of 10 will need more time or more money or both. So when we went, and that's the sort of the baseline approach, assuming that you will perform to that. On GOES, we chose a more, and sometimes you choose a more aggressive schedule for a planetary mission because you have a tight window for launch. For the GOES-R program, we chose to proceed from our confirmation first delivery on a 50% thereabout confident schedule, knowing it was aggressive but not unachievable because we understood the criticality of getting this measurement on orbit and because we thought we would challenge ourselves and we would track our performance against that. We never sacrificed the performance during that process, so we didn't skip tests that we thought were important or necessary in order to achieve that, but we tracked then the reserve depletion over time. And as David Powner mentioned, the negative performance over about 2 years from mid-13 to mid-15 were strong. We were not meeting our schedule, but we were still meeting the earliest schedule we could achieve.
Well, let me try to fit one more question in here to Dr. Volz. So, Mr. Powner, when the GAO had made 11 recommendations regarding JPSS, and NOAA's only implemented 2 of them, and 12 recommendations regarding GOES-R, and NOAA's implemented 4 of those. Can you explain the gap between the recommendations made by GAO and the ability to respond to them?
Yeah, a lot of those recommendations are to address the gap. It's on the contingency planning efforts, and Dr. Volz and I had a good conversation about this. I think a lot of them are in flight. They're not fully wrapped up yet, so we want to see more of that done to address a lot of the gaps. I think the issue with this poor schedule performance and whether it's achievable or not, I think we need to be more open with our risks. So when we were here in February talking about missed milestones on the GOES program, and we didn't think they were going to hit that launch date of March 2016, and NOAA had data saying that we had poor schedule performance for 2 years, our point is that you need to be open with your risks in order to hit your dates. When you're open with your risks, and I know this committee's been very supportive of NOAA to ensure that these satellites get up there on time. We need to collectively work on these risks and be open with them so that we can all collectively address the issues that are at hand.
Okay, thank you. And very quickly, Dr. Volz, on the life plan extension, Mr. Powner talked about NOAA should have disclosed that sooner, that data has been around since 2005. It almost, if I were a skeptical person, I think we'd extended the lifespan in order to make sure that we don't look like there's a gap. Can you explain this?
Well, the particular study that Mr. Powner mentioned was a study from 2005 of whether we could expect the instruments to last longer than the contractual lifetime. But that's only a piece of the puzzle that we use when we calculate, when we estimate the projected future life of a mission. And one of the other pieces, which really required the expenditure of time, was with the GOES NOP, is to see how those satellites operate on orbit. This was the first flight of the Boeing 601 bus in a geostationary operation like we had for GOES NOP. We need to see, when we have a new satellite or a new capability on orbit, time on orbit to see how it's going to operate, what its performance is going to be. Are we going to see life-limiting features start to develop? So it took many years of watching those satellites to operate from 6, 9, and 8, and 9 when they were launched, to develop a confidence in the family of satellite buses so that we could then say, all right, now I'm comfortable saying the projection life will be longer than it is. And that's where we came to about it this time last year.
Thank you, Mr. Chairman.
I'll recognize the gentleman from Georgia, the chairman of the Oversight Committee, Mr. Loudermilk, for 5 minutes.
Thank you, Mr. Chairman. I want to continue on with the line of questioning that my good friend Mr. Byer brought up. And Mr. Powner, you brought up the slides and the charts indicating the life cycle, the launch dates, and now we're extending the lifespan and the useful life of the both satellite programs. It's been extended by 3 years. And Dr. Volz, you just mentioned that there was other data that was considered beyond just the 2005 documents that was provided to this committee. One question, why was only the 2005 document provided to this committee when we requested data to back up why you're extending the lifespan of these satellites?
Well, actually, sir, in the submission in response to the letter we received, we submitted that study, but also an analysis and explanation of how we did use the on-orbit performance validation of these instruments over time and the satellites over time as one of the rationales for extension. And also what we also provide on a regular basis is monthly status reports on all of our satellites, and we provided a couple of examples of the statusing of every subsystem of the spacecraft that we do on a routine basis. So we haven't provided that, and that's a good point that Mr. Powner made. We haven't provided a regular routine mechanism for what the general health is of all our satellites. And one of the observations I had to my team is that we should be doing that. So on an annual basis, at least, providing an update of the health of our constellations overall and where we think, so we don't have a 10-year cycle for updating lifetimes. We talk about it on a regular basis as part of our annual reporting.
So is the studies that you're referencing as extensive as what was done in 2005?
No, the study in 2005 was a specific request to ITT, the instrument vendor who built the sounder and imager for the GOES NOP series and the previous ones as well. The study was specifically directed to say, although the instrument was designed for a particular lifetime, what does the vendor think the likelihood of that instrument lasting well past that lifetime? So we really had to go to the vendor who built it, who knew all the parts, to say exactly what do you think analytically, pre-launch, these things are likely to see. So that's one piece of it. It's a very specific analysis. The analysis I mentioned from our operations team looks at all of the operating performance of a series of satellites and watches each of those from a day-to-day, month-to-month basis, and then from that develops a statistical understanding of the likelihood of continued operation of features that may show up in initial wear factors in the spacecraft that we need to understand as they age on orbit. So it's different kinds of studies.
The information you provided the committee said that increasing the lifespan of the satellite by 3 years is plausible.
I think that's a reasonable way to put it. Yes, sir.
Well, the definition of plausible has actually 3 definitions: possibly true, believable, or realistic. Which one of those is it? Possibly true, believable, or realistic?
I'm not sure they're all mutually exclusive. I would say it's a realistic assessment based on the knowledge that we have that these are likely to survive through this period. Okay.
So with that, by expanding it by 3 years, are we increasing the likelihood that we could have a data gap?
Relying on aging assets for a longer period of time is a riskier approach than I would like to take, for sure, sir. I would prefer to have GOES-R up there in March of 2016, as opposed to October of 2016.
Yeah, we want it to be a GOES-R, not a ghost.
I would, yes, but I would also want it to be a GOZAR that's functioning and capable and tested out, and not GOZAR that is rushed so that we prepare, so that it may have failures or it may have shortcomings or test incompleteness that we had to do in order to get it to launch.
I fully
on orbit.
concur. Mr. Powner, would you like to weigh in on the
Yeah,
feasibility, or are we increasing the possibility of a data gap, which could be
Well,
devastating?
clearly, there's the gap on the GOES constellation, the geostationary constellation. The potential for a gap in backup capability is that you could see from the chart there. There's a likelihood that we're going to have that situation. I think the key with the extension of these lifespans, no one needs to have a very clear policy on how they evaluate these constellations. I know we start with design lives, and then we evaluate the reliability and availability of the constellation through detailed analysis. On JPSS, they do a very good job. Okay, we have an annual update. On GOES, we don't see it. So I think there ought to be some consistency here, because when you start moving these lifespans, it really affects the timing of when we build and launch these future satellites. And we all know these two programs consume a large part of NOAA's budget. Maybe you could slow those down in out years, and budget could be used for other things. I'm not saying that these aren't important, they are, but there's implications to moving these lifespans out. You can't just move them out and then say build them as quick as we have with the original plan.
All right. Mr. Chairman, I see my time is up. I just would like to add that, fiscal responsibility, efficiency, taking care of taxpayer money is very important. But we're talking about an issue that can deal with the safety and the lives of others. So I yield.
I'd like to thank the chairman, and for Dr. Volz, we understand you've been doing this job now for just over a year. These challenges have been developing over time, and we know you're working really hard to make sure that these issues are addressed. From our perspective, I just be real quick before I hand it over to Mr. Barra. From our perspective, we learn that there's going to be a delay in launch for GOSAR, and at the same time we learn that we're going to extend the life of another satellite. We're going to predict that it's going to last longer, and it looks like it could be intentional, that we're just extending it so that we can get to the next launch. And I'm not saying that's what happened. I'm saying that, as Mr. Powner said, if there was more transparency, if we knew that well ahead of time, it wouldn't have appeared this way. So just I'm sharing my sentiments on that. So transparency helps us, and we want to help you. So I turn it over to my friend from California, Mr. Barra.
Thank you, Mr. Chairman, and thank the ranking member. When I think about weather forecasting, thinking about this with my district, state, and much of the American West in mind, because we're going through a devastating drought right now, and it's the fourth year of historic and unprecedented drought. When I think about my district, Folsom Lake, which supplies drinking water for close to 500,000 people in my region, is a historic low right now. So just having the predictability of weather is going to be incredibly important, because again, in California and in Sacramento, we have this dual risk. We have years where we have incredibly high flood risk, and then obviously now we're living through this drought. So better forecasting allows us to better manage a precious asset, water. And that's why I share the concern of my colleagues here. If there is a gap in that ability, that does put us at risk, it puts the nation at risk, and it really does make it difficult to manage. I'm going to shift a little bit. If in fact there is a gap, we know there's commercial weather satellites out there that are providing commercial data. Is that true, Dr. Volz?
I don't know of any commercial assets that are providing equivalent or equivalent data and observations to the nature of what we provide that support our weather services. So there may be specific measurements that might be available, but in general, there are no commercial assets of equivalent or capable nature.
So there's no commercial backup that would be available. NOAA's data that comes from GOES and the other satellites, that's publicly available to anyone who wants it, or is that sold commercially? So it's a public asset.
Correct, sir.
That's available to anyone around the world.
Correct. Just as other nations' assets and measurements are available to us and to others as well. It's in a global cooperation and sharing agreement on the observations for weather and climate.
And you'd consider that really be a critical public asset for the common good?
Yes, sir. Entirely so.
If we think about commercialization, then And this data, so if we were to shift from, a public expenditure for the common good to more commercialization of this data, is there a risk that, that's no longer available? Folks have to pay, subscribe, et cetera? Is that going to?
There is a perception, there is the approach that NOAA has, that we have, is that weather services that we provide, when the observations that feed those, are a public good and are necessary for health, safety, and security for the nation, for our citizens. And so the idea of commercial available data sets are not necessarily at odds with public services provided by NOAA. If we can find the right terms and conditions for which to work with the commercial side to use their data in our models, in our operations. Now, data which is restricted, which are only available to individuals, are not something that we would be consistent with that approach. It's not something we would support. Doesn't mean commercial vendors can't make observations and sell it any way they want. That's fine. That's certainly open to anybody.
But again, from my perspective, there is some concern that, if we're taking the taxpayer assets and then, contracting that out to commercial vendors to replace some of the work that NOAA's doing, you over time can lose the ability of this public good, this common good data set. And I don't know if that's a concern that folks at NOAA have.
That would definitely be a concern. If our ability to deliver on the services and the observations that are necessary for health and safety and for aviation safety and all the other operations that we do is restricted because the funds are diverted to a different approach, which is proprietary and controlled in a different way, that would be a negative approach that we would not support, and I don't support it. Okay,
and within knowing that, when we look at space exploration, there's what is ongoing both at NASA and what we're talking about here in NOAA, this public-private partnership that is emerging. If you're kind of forecasting where weather forecast, little oxymoron there, but if we're predicting where weather forecasting is going, where do you see this commercial public-private partnership in the near future?
Well, similar to what you referenced on the NASA side, there are features, there are capabilities that we already rely on heavily on the commercial side to provide. For the most part, well, we don't build our own launch vehicles. Commercial do that. For the most part, we don't build our own spacecraft. We go to commercial vendors for that. All the instruments we buy are from commercial vendors. So the extension, there's an extensive public-private engagement in the execution of our weather services. What we're talking about is the potential next step, which is to secure data as opposed to capabilities that we deploy. And I think there is an opportunity for us to do that in a way which doesn't sacrifice those public goods that I mentioned a few moments ago. So I think, and as the commercial sector becomes more capable and delivers and is able to deliver a more quality product, a data product, I think there's certainly a possibility for strong engagement that can fit within our business model and can support a commercial sector better.
Great, thank you, and I see. I'll yield back.
I recognize the gentleman from Ohio, Mr. Johnson, for 5 minutes.
Thank you, Mr. Chairman, and gentlemen, thank you for being here with us this morning. Dr. Volz, how many of the viable U.S. commercial providers for satellite data do you intend to bring under contract in the next 3 to 5 years?
That's a very open-ended question. It depends on resources. It depends on how many actually apply for a particular, if we go out with an RFP or a...
How many do you need to bring under? How many do you want to bring under?
I'm more concerned with getting a data flow, to getting the operational data I need. So if I get, if we go through with an approach, a pilot approach, and we find one vendor that has the quality set of information that we need and we can use that meets our criteria and that is financially viable, that's a satisfactory result for me. If I get 3 or 4 competing and they're all providing something that I can afford to support several because I need the data from several, I can support that as well, subject to availability of funds and the cost points on these vendors.
Okay. Has NOAA done a cost-benefit analysis of gap mitigation alternatives to determine which ones are likely to be the most effective and worthy of investment?
When we went through the gap analysis and the exercises in 2011, 12, and 13, we had a report called the Riverside Report, which I imagine you've already read, which identified a number of mitigation approaches to lessen the impact of loss of a major asset. We selected a number of those to complete. We did not do and have been executing on those mitigation approaches. We did not do an a allocation of 1 through N to say which is the most effective and the least effective, but we saw they applied to different areas of our observing system, and we've applied the ones that were possible to affect, and we have been working on those.
Why do you not see the need to do the mitigation to look at the most effective?
I would say that we did that in I wouldn't say ad hoc, but in a best effort approach. It's hard to do an assessment of a particular measurement, what's the benefit of that to an integrated global model, which relies on multiple inputs to say. So I would say probably the difficulty of doing a cost-benefit analysis when the output is the value of a weather product, which, you know, 3 to 5 day or 3 to 7 day forecast, it's very hard to quantify the value of that from a cost of approach. We do look at the efficacy of those approaches. Is it a necessary part to address a particular measurement capability? And we did prioritize. We put our effort and our attempts into working on those more importantly.
Sure. As a general aviation pilot myself, I can tell you that the accuracy of that data and the ability to look out and get those accurate forecasts, both near term and long term, are important. Have any studies been performed on the costs, benefits, and trade-offs between different potential launch dates for the later satellites, such as GOES-U or for JPSS-4?
Yes, sir, and that points to the excellent point that Mr. Powner brought up, is that what can we do in the latter years once we get to a robust state, which is accomplished by getting GOES-R and GOES-S launched, do we have to launch GOES-T and U on a rapid time frame? And the answer is probably not. We would launch on need at some point when we get to that. So we've looked at, there are two comparisons here. One is the cost of storage, if we build and then store, and the other is the cost impacts of delaying the development. And we have done the assessments, and based on industry assessments and industry models of the efficiency of building in a rapid sequence is more effective in terms of buying the parts and getting the workforce engaged and buying down the risk of the implementation than building one, waiting a few years, building a second, and building a third. So we actually have seen that the examples from aerospace and from other industry examples of the efficiency of build first, launch later if necessary, has a certain cost benefit from the build and development cycle, and a significant risk benefit because you buy down the risk by building them all at the same time when you have the parts and the availability and the engineering.
Okay, all right. Earlier this year, your office hosted a community engagement workshop to inform outside groups in the commercial sector of progress NOAA has made for incorporating commercial technologies, and this week you hosted another such event. What updates occurred between the previous workshop held in April and the one this week? What did you learn?
In the April workshop, we talked mostly about principles, about the engagement desires, what we would like to do going into the future. In the workshop we had just this week, we spent a great deal of time talking about the actual process by which we would use data, how data are used from observation to services and products, so that we were very clear and very articulate in trying to explain, we'll discern how articulate it was, depending on the feedback, to explain how the data are used in our systems and how different vendors can tailor their business models to deliver data to us at different places in our value chain.
Okay. Are you talking to individual companies as well to get a broader perspective?
We have gone out with RFIs asking for inputs on particular measurement types. We've gone out with RFIs recently, just in August, about technology, next generation technology approaches that they think are worthy of investment or are ready for application, ready for prime time as operational. We have not, in terms of the overall engagement, we have talked on a one-on-one basis. I have not, but some of my staff has on where they keeping us informed on where they are in their development cycle and where we are in our process cycle. In general, I'm trying to talk to them all at once so that we have these workshops on a regular basis so they all see, everybody can see where we are as we move forward.
Okay, all right. Mr. Chairman, I yield back.
I now recognize the weather guru from California, Mr. Perlmutter, but I would warn the witnesses that his
Colorado.
I apologize. From Colorado, I would warn the witnesses that his jacket is off and his sleeves are rolled up.
Okay. Thank you, Mr. Chairman, and thanks for holding this committee hearing. And to you two gentlemen, thank you for being here again. These are very important assets of the United States. As Mr. Loudermilk said, dealing with life, limb, and property, as well as science. And, I think I mentioned the last time you were here, I've been working on this since 2009 and 10 with NPOs. And what I'd like to do is just sort of go back to basics and understand the structure, the decision-making structure here. So I come from a construction family, and with respect to JPSS and the GOES systems, am I correct when I look at it as NOAA is the owner, NASA is sort of the general contractor, and then the private companies, the Lockheeds, the Balls, the Orbital ATKs are in effect the subcontractors. Is that a fair way to describe this? And this is to both of you. So Dr. Volz.
Yes, except I'd add a nuance there. Yes, NOAA is the owner, but NOAA is also the architect. Okay. So the architect doesn't just give the plans and walk away. The architect is there with the general contractor and is there when the general contractor sometimes is talking to his subcontractors to make sure that what he had in mind in the architecture is what is actually being implemented. So that's the role NOAA plays. We do not have the engineering depth that NASA does, and we rely on that depth. But we're there with the requirements, with the user community interfaces so that we know what the end use is of every one of these observations, which allows us then to work hand in glove with NASA and with the major contractors to make sure that end use is remembered, is kept in mind as you go through the whole development process.
Mr. Powner.
Yeah, and I would just add that the contracting situation with the spacecraft, each sensor, and the ground component, they all have prime contractors with subs. So you have many contractors and subcontractors involved with each of those many components.
Well, the reason I'm asking that question is because whether it was NPOs or now GOES and JPSS, there is a little separation between NOAA as the owner architect, if you will, and the general contractor, NASA. Before it was NOAA and the Air Force. Mm-hmm. And we've had, obviously we wouldn't be here if we weren't having some delays and some hiccups and how these things are proceeding. And sometimes I feel like NOAA, gets hammered when in fact it's really been either the Air Force or NASA that has caused some of the hiccups. And they're not sitting here today. Am I mistaken in that at all?
I think we can go too far with the analogy between NPOs and where we are now. I believe in the NPOs days there was a greater separation between the different owners and executors of the program, which led to some of the disconnects, some of the problems. The requirements flow down into the implementation was much more complex under NPOs than it is now. I believe now with the NASA-NOAA relationship and the NASA-NOAA contractor relationship that we have on JPSS and on GOES-R, we have a much better connectivity across that line. There's clear leads and follows, but it's much better than it has been in the past.
Let me tell you where I'm going with this, because I'll run out of time. And, as a Coloradan, we were disappointed when Ball didn't get the follow-ons in the JPSS program. NASA was the acquisition point person or point agency, and obviously the contractor there. What I'm concerned about is just, as Mr. Powner was saying, the Navy has a very good system of building submarines. They really do have an assembly line approach. And given the fact that we've had these delays, Dr. Volz, more to you, but also to Mr. Powner, shouldn't we be trying to do something like that with these satellites so that you can get them done in a way that's timely, that's well tested? Am I making a mistake here?
No, I think what you have a perfect example between GOES and JPSS in that it is, if you're building a series, a fleet, it does make sense to define the requirements once and do the implementation once. And that's where we are right now. That's how we set it up with the program, with the GOES program. You still have problems, as we're talking about. That's why we're here, because of the issues in the development of the GOES program. But we hope that we'll work through those and overcome them. With the JPSS, the SUMI NPP JPSS program, we did not have that same construct. We were building them one at a time, and there are definitely significant inefficiencies in doing it that way. Whether it's an intentional change in a major subcontract, like the spacecraft from Ball Aerospace to Orbital ATK, or it's an unintentional change because the production lines have changed and the capabilities that the subcontractors change out and you can't control it. So by going with the one-at-a-time approach, you definitely are setting yourselves up for a more risky approach, which is one of the reasons the PFO, the follow-on to JPSS, is intended to be buy both at once, eliminate those risks of coming with multiple serial buys so that you do minimize the risk of implementation. And I'll let David answer too.
Yeah. We've had a lot of risks and delays on both these programs. I don't know why you'd add more risk with the that was our point on J2, and especially when we sat down on goes and the delays, and we said, okay, well, what's going to be different with your schedule performance? And they said, well, we learned a lot. Okay, and the second one, we're going to be a lot better at it. Well, don't you think that logic probably applies to J2? There's a lot of issues on J1, workarounds with subcontractors and the whole bit, that Ball Aerospace can lay out all those things. A new contractor doesn't have all that history going forward, so we think there is risk with that shift, and we're looking for more continuity where we kind of get an assembly line here.
All right, thank you, Mr. Chair.
I'd like to thank the gentleman from Colorado. I recognize the gentleman from Texas, Mr. Babin.
Yes, sir. Thank you, Mr. Chairman, and thank you, our witnesses. Dr. Volz, if the government has weather or climate missions that you could catch a ride on a commercial satellite to the benefit of all parties, it would seem to me to be a cost-effective and sustainable option. Has NOAA taken advantage of these hosted payload options for weather or climate missions? If so, why or why not?
You're correct. If we can find a ride, it's an appropriate, and that meets our requirements, it's an appropriate and potentially more efficient way to do it. We are suggesting and proposing that approach for our search and rescue and ADCS systems. It's called CDARS, which would use the Air Force's hosted payload solutions approach for buying spare space on commercial launch vehicles, or commercial spacecraft, not just launch vehicles. Yes.
Sure. Okay. Thank you. And again, since the President's fiscal year 2016 budget request, excuse me, transfers responsibility for developing climate instruments and climate satellites from NOAA to NASA, will NOAA funds that were meant to pay for such instruments and satellites stay within NOAA for use in gap mitigation efforts? Or will they be transferred to NASA to offset the cost of their development? And what effect would such development have on NASA's budget? Please provide the committee with a funding breakout of how this arrangement would look.
So we'll be happy to provide you with a follow-up on the funding breakout. From looking at the transition of the couple of measurements from NOAA to NASA, there was there were no funds transferred from NOAA to NASA. There were no funds allocated. We were underfunded to execute those activities on the NOAA side. It was a prioritization question, and the concern was they would have been left off the table entirely because they weren't funded from the NOAA side. It wasn't that we had funds that we should then move over to cover it somewhere else. So it was both a question of focus and let NASA do the climate, but also an inability on our side to support those programs at the because we had to support the primary weather mission. That was our focus.
Okay. Then, Mr. Powner, you seem to have major concerns about NOAA's transparency and openness with Congress. And what are the key issues that drive your concerns here?
So we had a hearing in February on these two programs, and then what happened was the lifespan extension occurred in April. The flyout charts changed in April. And we think if a major change occurs like that, this committee should have been informed. That's one example.
Okay.
Another example is I think the schedule performance could have been disclosed much more directly and openly to this committee when we had that hearing in February.
Absolutely. Mr. Volz, would you like to comment on that?
Sure. On the first one, the flyout chart change, that's on me. As I came in from NASA, I remember looking at the flyout charts over the years and trying to understand, what the logic was in those. And I brought in with my experience, there are different analyses, different approaches to assessing the extended life, since I'd done that for many years at NASA, that would be applicable, I thought, to these systems and these programs. And that's what I asked for. I was not aware, it was my error not knowing how sensitive it was, how important it was that we communicate those. So we will, as I said, we will make that a regular thing in the future. On the other question, which I'm drawing a blank on, what was the second one? On the schedule performance, that's a fair point. And to the degree that we're not communicating well quantifying the risk that we see in the execution of these programs, I think we need to do a better job of that. We work regularly with your staffers, with the committee, with our quarterly briefings, and to the degree that those are not communicating appropriately, I'm happy to find a better way to do that to improve that communication.
Okay. And once again, Mr. Powner, one of NOAA's challenges is that it needs to obtain more and better weather data with less money. One way to do that is to buy data from the commercial sector instead of trying to launch satellites by themselves. But NOAA's satellite division, NESDIS, has also been delegated the authority granted by Congress to the Secretary of Commerce to regulate these new commercial providers, and they're having trouble granting licenses on a timely basis. Isn't it a conflict of interest for a bureaucracy to regulate the industry that is competing with its traditional satellite programs? And should the authority to regulate and promote this new innovative and money-saving industry be moved to the Office of the Undersecretary for Oceans and Atmospheres instead of being buried inside NESDIS?
Yeah, that's, in terms of where that should reside, I think the key point here is this. We need robust constellations for both GOES and JPSS. We're always going to have NOAA own and operate these big satellite programs. That's not going to go away. But we need to supplement these constellations with commercial data to ensure that we have a robust constellation. So I think where everyone wants to go with the use of commercial products and the like, we need to look strongly at that to build the most robust constellations. That's what's most important for the American taxpayer in this country.
Absolutely. Okay. Thank you, and I yield back, Mr. Chairman.
The gentleman yields back. I now recognize the gentleman from Florida, Mr. Posey, for 5 minutes.
Thank you, Mr. Chairman. Dr. Volz, in your opinion, how likely is GOES to meet its launch date of October 2016?
I think our current performance and the schedule execution is strong, and I think we have margin. We definitely have margin against our August delivery date to the launch site. The poor performance that was mentioned by Mr. Powner in the 2 years leading up to the thermal vacuum test in July and August is real. And following that, when we reestablished this schedule for an October launch date, we provided a new schedule approach for Lockheed Martin and for NASA and for NOAA to work together. Since the September, October, November period, as opposed to 10 days a month of reserve being used up, they are ahead of schedule. So the way that we've rephrased the schedule and reframed it with reserve appropriately has been working, and the program is working on schedule since that time, in the face of problems and issues like we typically see during integration and test. So I'm reasonably confident that we will meet the October launch date.
Okay, thank you. Mr. Powner, you see that thing the same way?
Well, we are aware of, there's some failed transistor parts that affect battery operation and the whole like. I think that's been a key risk going forward, that we have heard that that October launch date possibly could be at risk. That's a key issue. I don't know where we're at on that right now, but that's something that we're watching. We're still cautiously optimistic on these launch dates going forward because we've heard indications that there's still some risk to the October 16 date.
Okay, well, you partially answered my next question for Dr. Volz, and that is, what do you see as the biggest factors that could cause another launch delay?
We have finished, well, we have still some mechanical environmental testing ahead of us. And the likely factors on the GOES-R spacecraft, since it has been integrated and the particular transistor failure in the power regulating unit has been corrected and the pieces are back in integration, is the nature of similar things like that happening over which that could be a bigger problem that takes time to resolve. A parts problem, a mechanical problem during test. Those are still ahead of us. So until we get through the mechanical testing, the vibration testing, acoustic testing, those are major tests that we still have to complete. The ground system is solid. The radar, the antennas are completed and ready for receipt. The user community is prepared. It's getting the spacecraft through the last 8 months of environmental testing to launch, which is always a challenge, but that's, I see, as a systemic challenge that we have for the program right now.
Okay, thank you. What are some of the potential impacts of a delayed GOES-R launch? Will it increase the life cycle cost?
It will not increase the life cycle. Well, depends on the type. If we have a major issue, there are major, within the expected range of a delay here or there, or the operations that we have to do to execute, we're operating within the life cycle cost budget, within the annual budgets. So I do not expect that, based on what we see now, that we need additional funding for the GOES-R program.
Okay. What is the current estimated time during which GOES constellation will not have a backup satellite available?
And that's a good segue into what is I don't predict that we will have any point that we won't have a backup satellite available based on our estimation of the current life expectancy of these satellites. However, we are all only one failure away from losing a satellite. That can always happen. So between now and the launch of GOES-R, our estimation is the satellites we have on orbit are functioning, aging, and healthy, as I said in my introduction, and I do not expect that we will have a gap. However, if we lose one of our assets, we do have a backup in space. And if we lose that if we're reduced to 2 satellites, we have anticipated this possibility and worked cooperative relationships with our international partners so that they could loan us a satellite in the dire circumstances that we have 2 major system failures. We've worked this with EventID and over the past.
And I was going to ask if it's ever happened in the past.
It has in the past occurred that we had to borrow some assets from our foreign partners, and we've contributed assets in the same as the global constellation of geostationary satellites have needed the partnership sharing arrangement that we've had. It's been successful and has been exercised 2 or 3 times in the past.
We had a hearing earlier and had testimony about the sunburst that crossed our orbit last year that we missed by about 1 week. That would have virtually, some experts say, knocked out every single commercial satellite. How would that have affected yours?
I don't know the magnitude of that particular solar event that might have hit us. Our satellites are hardened for what we understand what the normal environment is. Normal meaning some deviation from the normal environment. A major solar storm would have an impact on all of our satellites, and major is hard to determine exactly what it is. And but we are as vulnerable as some other satellites to major solar flare events. And we do what we can to harden it. We may be more hard than some of the commercial ones, but it's still the event of a significant event would have an impact on us.
Mr. Powner, you want to comment?
I have nothing further to add on that.
Yeah, and I'm concerned about, you know, what we do to harden these, you know, how much they can be hardened, if there's any cost that's prohibitive in doing that. I just don't think that Congress, quite frankly, or the public communications industry has taken it serious enough. We had experts come in here and tell us basically it would change the world as we've known it. Mm-hmm. They say the impact would be in the trillions, and they talked multiple trillions. They wouldn't even dare attempt to quantify it, but we seem to be doing so little about hardening these for the solar eruption is what they called it, or EMPs. Mm-hmm. They just dismiss that as well. Before somebody used an EMP against us, there'd have to be bigger problems, which is not true. And is there a plan that contains NOAA's ongoing strategies to mitigate a satellite data gap?
Yes, sir, there is, and it's been exercised for the last several years for our program, and that is the point of getting JPSS 1 and 2 and the PFO under contract to get to a situation, and directly to your point, where we have a hot spare on orbit for our polar and our geostationary satellites, and in the event of a significant event, we're thinking about a satellite, a meteorite, but it could be a solar flare, we can redeploy an equivalently capable asset within a year. That's the objective, and that's one way, rather than trying to harden a satellite against an unknown size of event, is to have a replacement satellite that is readily available. And when you look at the GOES-T and U available, we won't necessarily launch those to have them sit in orbit. We could have them sitting on the ground for deployment in the case of an event like that as a replenishment when we have a failure. So our programs do support getting to a robust state, but we're not there yet.
That's a great plan, but if we had an impact, the consequence of the one the scientists told us last year, it's very possible there would be not be an electronic grid to enable you to send up the replacement within a year.
Fair enough. The magnitude of the event is hard. There are events of a size that we can't model for or plan for. But we are planning for the loss of satellite assets. There's something that may only affect the satellites and not the whole ground infrastructure.
Okay, Mr. Chairman, I thank you for your indulgence. I yield back.
You bet. Mr. Powner, would you like to address, I saw you maybe indicating you had a comment when he mentioned that the GOSAR delay could have an impact on life cycle costs. Did you want to say something about
Yeah,
that?
well, life cycle costs, so there are reserves, okay, and you have an overall life cycle. Any delay, there's going to be an impact on cost. I mean, this last delay, there was an impact on cost. So I just want to be clear on that. Any delay that we further have, there will be an impact on cost, and there will be an impact on the potential, increasing the potential gap in backup capability.
Okay, that's important for those of us on this committee to understand. I now recognize the gentleman from Alabama, Mr. Palmer, for 5 minutes.
Thank you, Mr. Chairman. I'd like to thank the witnesses. Mr. Powner, you mentioned that NOAA needs a clear policy on what analysis should drive the adjustment of satellite lifespans. Can you expand on that and briefly?
Yeah, so some background here. If you look at like what DoD does, they actually have very robust analysis on the availability and reliability of their operational satellites. To NOAA's credit on JPSS, they do a pretty nice job on JPS. They do an annual assessment on that availability and reliability. We don't see it on GOES. But even too, they just need to be real clear on what their policy is on how they determine the lifespan. So for instance, I've been doing this a long time, looking at NPOs for this committee, even prior to some of the dates that Congressman Perlmutter made. Our understanding is that the GOES policy is you have a backup on orbit. On the the polar constellation, we always thought the policy was you have a backup on the ground. But now I'm hearing a backup in orbit. We just need to be clear on what our policy is on ensuring a robust constellation. And it's there, NOAA is not always clear. They're not always clear, and we need to get that clarity so that we have a robust constellation.
Let me ask you this. How can NOAA determine that appropriate progress has been made on implementing gap mitigation activities? Mr. Powner.
Well, you know, we looked at this with our last review and we testified in February. There's a lot of good work on mitigation activities, and I do think there are some mitigating factors that yield greater benefits. We've heard like aircraft observations, some of the adjustments to the models and the like, and NOAA's working on those things. So a lot of that's being worked on now, and that goes back to some of the comments and questions earlier on our recommendations. We want to see some of those mitigation activities rounded out even further so that if in fact we have gaps leading up to March 2017, that we have some of these backup capabilities.
In that regard, and Dr. Volz, you may want to comment on this. And go back to Mr. Posey's questions right there at the end about having whether you've got a satellite backup system already in orbit, or if you've got backup systems on the ground. Do you have backup launch capabilities? Because if you do have a massive solar event or some other EMP type event, would you have the capability to launch more satellites?
We rely on the launch services provided through the national assets, the same launch service that are provided that support the Defense Department, NASA, NOAA. We all use the same commercial launch providers. In the event of a catastrophic loss of a significant asset, we also have the capability and to prioritize our mission over others, I believe. So I think if that were
what I'm
exercised, we
asking,
would
and you
rely
may
on
not
those.
be able to answer this if you're relying on other agencies, other parts of the government for the launch capability, but it's not just losing the asset in space. If you had a catastrophic event like an EMP where your ground systems are eliminated, do you have backup systems, or you may not be able to answer this, are there backup systems that could launch that have been hardened or that we could get in place to get something back in orbit?
And I'm not the right person to ask about what the capability, launch backup capabilities are for the nation.
All right, Mr. Powner, I'm going to go back to you for JPSS. Your report from earlier this year focused on a potential gap in the 2015-2017 timeframe. Are there similar concerns about a gap between the first and second JPSS satellites in the early 2020s?
The first and second satellite, we're not so concerned about a gap between the first and second, assuming we hit the March date and JPSS-2 stays on board. The issue with the gap between NPP and J1, you know, if you didn't have this recent 4-year extension on the lifespan, there would be a gap. So, you know, the key here is we hope that NPP continues to function well and we hope that J1 does launch on March 2017 so that we don't have a gap between NPP and J1. That's still a concern of ours. That's still a concern. Until we launch J1, we're concerned about a gap.
And if I may, sir, and I have almost the exact opposite assessment. Based on watching the SUMI MPP instrument and missions fly over the past 4 years, based on our analysis, our understanding, and mitigation steps we've taken in execution of those operations, I have a stronger confidence now that the satellite, barring a meteorite or some other activity, is likely to function for a great, many years, because I've seen these satellites do that over time. I think the uncertainty in launch and of the gap between J1 and J2 is because we haven't launched J1 yet, is a larger probability of something I'm more concerned about going forward. So, but we're talking about probabilities and risks, and we have to address all of these. I don't think that once J1 is launched that our risk of a gap is necessarily gone away. We still have to worry about getting J2 developed and delivered on orbit as quickly as we can.
The one thing, if I could add, I do think NPP overall is functioning well. It's not perfect. You can read their own availability analysis, and there's questions about ATMS lasting beyond the 5-year life, not a 9-year life. So there's watch items there, and we need to continue to watch that. So I don't want, we need to be real clear that there still are risks with NPP.
Mr. Chairman, I see my time has expired.
I thank the gentleman from Alabama. We're going to go into a second round of questions, and I recognize myself for 5 minutes. Wanted to share with you guys some of the challenges I see going forward as it relates to the commercial data buy. The President's budget request is due to this Congress in February. We'll do a budget process in March. Then we'll be doing authorizations along this way and appropriations even before and then, or I should say after. What I would be interested in is what that number might be. And I know you probably don't have that number for a line item for a commercial data buy. I want to be clear that we're expecting that, and I'd like to, if you're able to provide that to us even before February, it'd be very valuable as we go through the authorizations and the appropriations processes. So just, you're under no obligation to give us anything until the President's budget request. I understand that. But if you can help, we want to be helpful as well. So that would be good. On the commercial space policy that came out on September 1st, it's been open for comments. The comment period closed October 1st. There have been 15 comments. Do you have a timeline when the final policy might be released?
Yes, sir. And excuse me, we had 15 respondents with it. When we looked through the responses, we came up with on the order of 90 different actionable comments that we think should be addressed in some way or other. NOAA has set up a team and has a team to review those and adjudicate those. I'm expecting, and I've been told by the management within NOAA that we expect the revised policy to be coming out within the coming weeks.
Oh, that's great.
And in the meantime, we've been working the process. The workshop on Monday was addressing that, and we would like to follow up with the release of a draft process for comments, just like we did with the policy, within a few weeks after the release of the formal policy.
So after the release of the formal policy, there will be more comments?
No, a draft release of the NESDIS process,
Oh,
which is the next level of detail down about execution of an engagement with industry.
Got it. And when you can expect that? We said we can expect that a couple of weeks after?
After the release of the NOAA policy.
Fantastic. So we're talking about January, February?
Yes.
Okay.
Yes.
Fantastic. Let's see. I want to go through a couple of comments that, or I should say, statements that were made regarding the space policy, and I want to get a reaction from you on it. One statement is that, and I'll just read it. It says, in its entirety, the latest iteration of NOAA's policy fails to make a distinction between raw satellite data that would be ingested into NOAA's operational weather models, which is the intended focus of this policy, versus the output of those models and derived data products. It is the full, free, and open access to model output, derived data products, and current ground conditions that underpins the robust U.S. commercial weather sector. Do you agree there's a difference between the output and the raw data, like the satellite data coming down from the satellites?
Let me predicate this with saying I'm not an expert in WMO 40, which talks about the essential versus non-essential or additional data sets, and they address mostly the issue of the data. So there is a difference between input data and output products for certain. no question about that. So simple answer to your question is yes, there is a difference between those. And I don't know that the policy was meaning to address the output products, the output services, as they are free and open to all.
Okay.
But is focused on, from my perspective, in using commercial data in our operations, is how we deal with the data that we receive from the vendors, which is the input data that you're referring to.
So going back to your mention of WM40, there's another statement here. It says, WMO40 resolutions 40 and 25 explicitly permit private sector companies to restrict the redistribution of their data and allow those same member countries flexibility and discretion in determining which data sets are freely exchanged and under what conditions they choose to do so. So it looks to me like under WMO 40, private industry that is providing data to augment the numerical weather models, that data should be protected. Would you like to make a comment on that?
Probably not. I am not
Probably
a WMO,
not that you don't.
I'm not a WMO 40 expert,
Okay.
so I don't know all the nuances of it. So certainly, I probably should let it go with that. We'd be happy to have a different separate conversation related to WMO 40.
I'd like to get these kind of resolutions in this final space policy coming from NOAA, commercial space policy. And I know it's going to be in a couple weeks, but these are the kind of things that absolutely must be definitively determined before, if we're going to have a robust commercial segment that can augment our numerical weather models and save money for the taxpayers. And that's my concern. More data, better data, and cost savings to the taxpayer. And I think we can do that, but we've got to be really clear about what's required here. I've got about, I'm out of time. So I'm gonna stop now and recognize the gentleman from Virginia, Mr. Byer.
Thank you, Mr. Chairman. And Dr. Volz, in Mr. Powner's testimony, he talked about how the delivery of one of the satellite's critical instruments, the ATMS, Advanced Technology Microwave Sounder, had been delayed. But in the last quarterly update that this committee received, NOAA had said that it had to be delivered by the end of November to maintain the JPSS-1 launch date. And in your testimony now, you say that you can maintain that launch date despite the fact that the AMTS won't be delivered until the end of December. Can you explain the conflict?
The ATMS delivery date, per the plan that we established in the summer, was no later than the end of November to support the plan going forward to a December 2016 launch date, correct. The ATMS has slipped to now late December, potentially early January. And we have had to look into we have had to take time out of reserve, schedule reserve. The late November date was planned for and did not encumber any of the reserve, the schedule reserve left in the schedule beyond the November. We have had to had to debit against those reserves to accommodate the late delivery of the ATMS.
So you had flexibility.
We still had some flexibility. It wasn't a no reserve date for delivery in November. We have flexibility. We've been using it.
Great. In your testimony, Doctor, you talked about that the GOES-R team is applying all the lessons learned from the last 2 years to do timely and successful completion of GOES-STU satellites. Does the same theory work with the JPSS? Because I know you've now moved to a new contractor for JPSS-2. Any risks because you're not building with the old contractor on what you learned doing that?
Yes. I agree with Mr. Powner that going to a new contract, so let me go 2 points. First, what I said is we're applying the lessons learned over the last 2 years in the integration test of GOES-R to make sure that the schedule we have laid out through this time next year, October of next year for the launch, includes those lessons learned. And that's why we have confidence based on the last 3 months that we're meeting schedules. We still need to revisit what that means for the GOES-S, T, and U schedules as we roll through that, and we're doing that right now. Now, as far as changes in the contract, going from one spacecraft vendor to another for the JPSS, that does increase risk. That's a factor. It's a risk factor now that we've added to the system. It was not there before, and I agree with you that it does. You can't say that's not the case. Now, whether that risk is where that ranks in the overall risks of different risks within the program, including cost and schedule risk, is something we had to look at when we made the procurements, when we went through the process. So it is an increase in risk, but not necessarily an increase in the overall programmatic execution risk, because we have to look at many factors when we consider program risk.
So clearly, when you made the new award, it was understanding that this was a piece of the overall puzzle.
Correct, sir.
Okay, great thing. Mr. Powner, you had said the very attractive idea that perhaps Congress could reduce its expenditures in upcoming years. Can you expand on that a little?
Well, clearly, when you look at the out-year satellites, the follow-on for the polar constellation, and then when you get into the out-year GOES, there's a question about what's the most economical way to go forward. Do you build everything and as quickly as you can and get economies of scale there and perhaps store them on the ground? Perhaps. Do you perhaps slow down the acquisition of some of those out-year satellites? Perhaps. And I think and I know this committee, we've worked with both your staff and the majority staff, they're looking for analysis. There was a comment made that Congressman Johnson asked a question about this, about trade-off assessments. I'm not aware of those trade-off assessments that has satisfied your staff on this committee. I think they need those trade-off assessments to make the right decisions on out-year deliveries.
Okay, great, thank you. Dr. Volz, did you have any comments?
Yeah, I would like to respond to that, and I agree entirely that that the out-year execution needs to be addressed. What we have focused our activities on over the last 5 years, as we came to the assessment of risk on both the polar and the geostationary satellites, is that we did not have a robust configuration on orbit. Our first and overriding priority was to get to a situation where we were fault tolerant. We had a single fault. You know, we could suffer a loss of a satellite asset and not disable the weather system. And so that has dictated the aggressive approach to building the GOES-R satellites and our aggressive schedule, so that as we went through what could be a mission-ending failure. The same with the JPSS. So that has been our primary motivation. Once we get to that, we're comfortable in that risk-tolerant or fault-tolerant situation on orbit, exactly as Mr. Towner mentioned, we can look at what is the cadence that we need to launch. But we need to have the assets available to have the flexibility of making those choices. Until we have that, then we can't do anything to make it better or worse.
Thank you very much. Mr. Chairman, I yield back.
I'd like to thank the ranking member, and in closing, very good to see you down there. Recognize the gentleman from Alabama, Mr. Palmer, for 5 minutes.
Mr. Chairman, thank you for recognizing I'm trying to do my job.
It's what the taxpayers in Alabama expect.
Exactly. Mr. Volz, the President's budget requested $380 million for the Polar Follow-On Program. Having seen the cost overruns and delays faced by the current satellites, I think maybe you can understand our hesitation to fully, or some of us, our hesitation to fully support fully funding this program. How exactly are these funds going to be used?
Thank you for the question, sir. The Polar Follow-On includes the third and fourth series of the JPSS satellites. The funds for the initial $380 million are primarily to start, and to the extent about 85% of those going directly to the instrument providers who have built the instruments for SUMI NPP and JPSS 1 and 2. The benefit of this approach that we've tried to articulate is that we are buying the satellite instruments, which are the highest risk, potentially the most impactful elements of any satellite system, at a time, at a bulk buy. We're buying 2 at once, maximizing the efficiency of the procurement at a time when the instrument vendors are ready to build those, having just finished the same instruments on JPSS 2. So the money will be going, to the extent of 85% of it, or 90 or thereabouts, directly to the main 4 vendors who are supplying instruments for the JPSS 3 and 4 satellites.
Are those vendors building the components that you think are most crucial?
They will be
You say
prioritizing.
That's 85% of the money, so the majority of the money is going to that?
Yes, sir.
All right. Let me ask you one other question. I'll ask one other question, Mr. Powner. In the GAO's opinion, would NOAA incur higher cost if they did not receive all of the requested funds to initiate the Polar Follow-On programs?
I'm not certain. This is back to where the appropriate analysis and the trade-off assessments needs to be given to this committee, to GAO, so that we can actually answer that question. You need analysis that supports it.
Well, to close this, and I assume this will close the hearing, I just think, handing NOAA another blank check to build satellites when they can't get the ones that they have off the ground, that it appears a bit irresponsible, Mr. Chairman, and I think NOAA needs to fix their systematic problems that have plagued the program for years before we throw any more money at it. I yield to balance my time.
I'd like to thank the gentleman from Alabama. It's a very challenging issue that you know, we have delays, we have these challenges, and it seems the only answer is more money, more time, more money, more time, and if we don't provide it, then we have, you know, quite frankly, even bigger problems with data gaps and the inability to predict weather. So it puts us here in Congress in a tough position when we have these issues. But I want to close on, you know, I really believe that we can augment a lot of these challenges with commercial data. I believe that it can reduce the cost. I believe it can prevent these kind of scenarios from even occurring if we do it right. And we might not be there today, and I understand that. These kind of things take time. What I'm very grateful that in the next couple of weeks, you know, before the end of the year, we're going to see a final commercial space policy from NOAA, and then more policies that come after that, so that our, you know, private sector knows how to work with NOAA in order to provide the data that can augment our systems. When I see that final commercial space policy, I would really like to see two major things. One is that there's a difference between upstream and downstream, a difference between flat-out raw data, ones and zeros coming off of a satellite, and the downstream, which are, you know, the end products that are available to the public and in the national interest. And I'd also like to see a very clear resolution that, in fact, WMO 40 and WMO 25 explicitly permit private sector companies to restrict the redistribution of their data and allow those same member countries flexibility and discretion in determining which data sets are freely exchanged and under what conditions they choose to do so. I think that's important as we develop this commercial industry that is going to be good for the taxpayer, good for those of us who are trying to protect lives and property. And I think these are important issues that need to be put into the commercial space policy. With that, I want to thank our witnesses for all of your time today. Thank you for the hard work that both of you do. And with that, we are adjourned.